Hello and welcome to the Unit 12 podcast on nuclear chemistry. Today we're going to be discussing section 4.4, unstable nuclei and radioactive decay. I'm Mr. Sakaguchi,
I'm Mr. Lin.
and let's get going. Radioactivity is something that emits from a substance that emits radiation. And radiation are rays or particles that are emitted by radioactive isotopes.
And this is the result from a nuclear reaction. And a nuclear reaction is where there's a change in the nucleus of an atom.
And normally electrons are involved in these reactions, but there are other particles that we'll introduce today as well. The emissions are due to unstable nuclei, and we'll talk about why these nuclei are unstable in the first place. And you want to do last term?
Yeah, fine. Radioactive decay is due to unstable nuclei from generally from a peculiar ratio of protons to neutrons. We'll get to that.
One of the major forms of radiation is alpha radiation. This is radiation where the particles are attracted to a negatively charged magnetic plate. Alpha particles are composed of 2 protons and 2 neutrons, which is basically the nucleus of a helium atom.
Minus the electrons. There's no electrons present in that. Also realize that as far as the types of radiation are concerned, alpha radiation is, in a sense, the least dangerous and can be blocked with a sheet of paper.
We can represent alpha particles either with helium like this or with alpha. This represents a nuclear reaction involving an alpha particle emission. Remember, this is the mass number, which is protons and neutrons. This is the atomic number, which is just protons. So notice the change. When this gets emitted, notice how the mass number goes down by 4 and the atomic number goes down by 2.
Beta radiation is the second type of radiation we'll be discussing. And these are negatively charged, so they deflect towards a positively charged plate. They're very fast moving. It can be represented by either E or this Greek beta, capital B beta sign.
Right, and one of the things to note is that this is the result of a change of a neutron. The neutron in the nucleus basically breaks down into 2 particles, one being a proton, which remains in the nucleus, the other one being the electron, which actually gets ejected out of the nucleus, and that's the particle. And here we have a nuclear reaction that kind of illustrates the beta emission. So again, notice how this is our mass number, the total of the mass numbers are equal, and then the atomic number, this is 6, this becomes 7 because this is -1. So notice how the atomic number increases by 1 and the mass number doesn't change.
Right.
The last form of radiation is gamma radiation. This is also known as gamma rays. And gamma rays are high radiation that possess no mass and are not attracted to either positive or negative fields.
And these are the dangerous parts of radiation. It's usually associated with all types of radioactive decay. It's shown by the symbol of, well, it's massless, so that's why the 2 zeros. And then this is the lowercase gamma symbol in the Greek alphabet. It has no particle associated with it, so it has no electrical or magnetic charge. And it's associated with most of the mass loss during a radioactive decay process.
Yeah, that's true. Stability, and Mr. Lin hinted at this earlier. So why are some atoms stable and others are not? And this is due to the proton-neutron ratio.
Right, so there's a certain balance between protons and neutrons because we've got all these really strong forces in the nucleus tightly jammed together. And if something is not balanced properly, then things are going to start breaking off and just snapping apart. And the result of this is radioactive decay, which causes radiation to be emitted.
Yeah, so you can see here, if this is our band of stability. So this represents the more stable isotopes. If you're above or below or beyond our band, then you're going to give off some sort of radiation in order to work your way back towards the band of stability.
You'll see with the earlier elements, as denoted by the number of protons earlier, the earlier elements here, in the beginning, most of the elements are stable with a 1-to-1 ratio, but then as it becomes greater in the periodic table, the number shifts, and now you start seeing things like 1.28 or greater, and as a result, you start having more and more radioactive decay because it's deviating more and more from a 1-to-1 ratio.
Right. That's it.